Welcome back to this geometry course. We're going to be going over unit 3, lesson 3.2, three ways to prove triangles congruent. If you haven't watched 3.1 already, I highly recommend you do so. But of course, let's get right into it. I don't want to waste any more of your time. So we're going to learn, of course, right, like it says in the lesson name, three ways to prove triangles congruent, right? And there's actually going to be four ways, but you'll realize that the fourth way is really just disguised as one of them. But anyhow, first important thing you should know is included angles and included sides, right? So you see this figure here, right? This triangle, and angle H is included by the sides GH and HJ, right? So angle H is included by GH and HJ. I mean, to me, that makes a lot of sense, right? When I think of included, it just means between. So you can kind of think of it as like angle H is kind of placed between these two sides here. Side GH is included by angle H and G. Once again, right, that makes sense. This side, well, it's between these two angles, right? So again, if you think of included, it just means between. That's how I interpret it. But that's useful to know, right, for these little congruencies we're going to learn about. So the first one we're going to learn about is side-side-side congruency. And what that states is essentially, and again, this is really important, make sure you know this. Um, if three sides of one triangle are congruent to three sides of another triangle, then the two triangles are congruent to each other. So essentially, you use this congruency when you have two triangles and they all have congruent sides, right? Like all three sides of each triangle are congruent to the other one. So let's look at this example here, right? So we're given GH is congruent to GK. I've labeled that on the diagram. Also, of course, we know HJ is congruent to JK. We're trying to prove that this triangle here is congruent to this triangle. How do we do that? We'll write the givens down first, right? So if our end goal here, right, is to prove that this triangle here is congruent to that one, well, look at this, right? We already have the sides. We have one of the sides. We have two of the sides, right? And this third side here, well, that's shared, right? So of course, remember, right? You can think of this as like the overlap or not overlapping, as the mirror image, right? Think of these two triangles as mirror images, and usually when you're able to notice that, it's a good sign that you're using the reflexive property, right? So you can say that GJ is congruent to GJ. And of course, now that you've proven that there's these three sides are equal to each other, right? We have three sides, right? Um, that are congruent to each other for these two triangles. You can go ahead and say that these two triangles are congruent because of SSS. Once again, that just stands for side, side, side. And usually what I like to do whenever I'm using triangle congruencies in proofs is label the steps where I showed where the sides were congruent. So, of course, right, we showed that three pairs of sides were congruent in steps 1, 2, and 3. So I wrote in 1, 2, and 3 there. Right? Just a good way to organize. An important thing to touch on before we move on to the next one is remember that correspondence is important, right, for congruent figures. What that means is if you're trying to use SSS, right, make sure like you prove that, for example, HG is congruent to GK, right? Not that HG is congruent to GJ. That doesn't make sense, right? Neither does HG being congruent to JK make sense. Right? Make sure they are corresponding, right? That's the only way you can actually use these uh, triangle congruencies here, right? So let's move on to the next one. SAS. SAS is side angle side, and what that states is if two sides of a triangle and the included angle are congruent to the two sides and the included angle of the other one, then the two triangles are congruent, right? Remember, right, included just means the angle between the two sides. So let's look at this example, right? we have VW is congruent to YW. Uh, of course, I marked those in the diagram. We also have those two sides that are congruent. And our end goal here is to prove that this triangle here is congruent to this one, right? How do you do that? Well, now think about this, right? We've proven that um, one pair of sides are congruent, right? Two pairs of sides are congruent. Now, can we actually use a third side here? Can we say that this is congruent to this? No, right? Because we're not given anything that suggests that. But what you'll also notice, if you really look at this diagram, is that these two angles here are vertical angles, right? Because we have the two straight intersecting lines. What that means is that these two angles are congruent to each other. And now we can actually prove that these two triangles are congruent because you have a side, right? You have an angle, and you have a side. Right? So yeah, that's a good sign that we can use SAS. And once again, number your steps to show where you prove them. So this is the side, right? I proved that the angles are congruent in step 3 here, right, with the vertical angles, and of course the side. So, and before I move on, again, this is an included angle, right? Make sure you're proving that the included angles are congruent to each other for SAS, right? Once again, included means between, right? This angle here is between these two sides. This angle here is between these two sides. So that's how you use SAS. Finally, we have angle side angle, right? There is another one, but again, I told you that's disguised. But we have angle side angle, which states that if there exists a correspondence between the vertices of two triangles such that two angles in the included side of one triangle are congruent to the corresponding parts of the other, the two triangles are congruent. This is again just a fancy way of saying that the angle, right, the included side and another angle have to be congruent to ones of the other triangle. So let's look at this example, right? I've labeled the congruent angles. You're trying to conclude that triangle SRT, right, is congruent to RTU, right? Or again, SRT, URT, right? Make sure it's corresponding. So how do you do that? Well, think about this. You have these pairs, you have one pair of angles that are congruent. You have another pair of angles that are congruent, right? So you can actually use angle side angle here because you'll notice that this side, right, is actually included, right? It's between these two angles, right? It's between these two angles. So you can use ASA, angle side angle, for this specific problem. And of course, right, that shared side here, right? Remember that's a mirror image kind of, right? It's overlap. It's the you can think of it as a line of symmetry, right? That's a reflexive property, and you can prove that these two triangles are congruent because of angle side angle, and once again, label your steps. So yeah, for this one, key thing to realize is that your side should be included between the two pairs of angles that you're proving congruent, right? So those are our three basic congruencies for triangles. Um, we have angle side, right? But and yeah, you can 100% use this in a proof, right? But what you'll realize is that angle side is actually just the same as angle side angle, right? And here's why. Let's look at this diagram here, right? I've marked the congruent angles, right? We're trying to prove that this triangle here is congruent to this one here, right? Well, oh yeah, also they give us that M is the midpoint of DF, which means that M divides DF into two congruent segments, so DM is congruent to FM, right? What you'll realize here is, well, you have an angle, right? you have another pair, right, for the congruent angles, and you have a side. You might be thinking like, well, nothing is being included, right? That side is not included between the two angles, so you can't really prove these two to be congruent. Well, the key thing to realize is that you actually can, because like you can prove that these two are congruent triangles, because these sides here, or these angles here, are also congruent to each other, right? The reason is, well, this goes back to like I remember I did an earlier example on this, but let's say this orange angle was 50 degrees, right? The red angle here was 100. That means because all angles in a triangle add up to 180 degrees, that these angles here would both have to be 30 degrees, right? And of course, those are equal to each other, right? So anytime you have uh, two pairs of congruent angles, you can actually say that the third angle is also going to be congruent. So once again, right, we have proven that these angles here are also congruent. Well, now you'll realize is, well, this is just angle side angle, right? Because you have an angle, you have an included side, and then you have another angle, right? That's, of course, angle side angle. But to make it less tedious, right? Uh, people invented angle side, so you don't have to do all of that, right? You can just say right away that you have an angle, and a non-included side, right? So yeah, when you're using AAS, make sure that your side is not included between the two angles, right? It can be, right? It could 100% be included, but for AAS specifically, that side has to be non-included. Okay, and yeah, again, right, this is just a proof. Make sure you label your steps. Keep on emphasizing that because it helps you so much when you get to like these complex proofs later on. But okay, lastly, I'm gonna go over why there's certain congruencies that don't actually work in your favor. Um, like you can't use them to prove triangles congruent. So the first one is angle, 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 right? You can't prove two triangles congruent to each other solely based off the fact that all the angles are congruent, because you will get a case like this, right? Where you have this outside triangle here, right? And you have this inside triangle. What you'll notice is all the angles are congruent to each other, right? The blue ones are incongruent, the orange ones are congruent, the purple ones are congruent. Um, but obviously these two triangles don't look like they're equal to each other, right? One of them is smaller. Um, so yeah, the key thing to realize is that for angle, 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 you can't prove congruency because the sides can be different lengths, right? Like for example, you see that side DE is not equal to AB, right? This is actually a congruent. This is AAA, like angle, angle, angle. You use for similarity later on. We'll learn about that later on. But specifically for trying to prove two triangles congruent, you can't use it. Um, why can't you use side-side angle? The reason you can't use side-side angle, once again, is because there's different ways you can form the triangle, right? So here we have an angle that is congruent, right? We have a side that's congruent, and we have another side that's congruent, right? So we have a side, and an angle. But you will realize, well, these sides, even though they're congruent to each other, these triangles look different, right? So the reason is because these other two angles here can change, right? So you can't actually use a side angle either. It doesn't work, right? Because once again, this angle here can change. Likewise, this one here can also change. So hopefully that made sense. As long as you understand that, first of all, you should understand what included means, right? Included means between. Um, SSS, side, 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 right? All three sides are congruent to all the other three sides. Side, angle, side. You have a pair of sides, an included angle, and another pair of sides. And then angle, side, angle, where you have two angles, and then you have an included side. Right? So once again, if you have any questions about this, right, uh, just leave it down in the comments. You can always just pause the video and just look at these notes too, um, if you work like that too, right? But I hope you enjoyed this video, and I'll see you next time.